Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Today we're going to learn lesson number 10. It's called Rational Expressions. And this page that I'm showing to you, essentially, I just want to kind of, let you know that we don't have too much more time left in the school year. And we essentially have, after this, 2 more lessons. And we wrap up with the treatment of Algebra 2 that you need to know to be able to do this in pre-calculus. And you'll find when you get to pre-calculus, you also learn Algebra 2 over there. It's a little bit more advanced. But when you collect all of the material that you learned this year along with next year, you basically are leaps and bounds further away from most students in America. So, just kind of giving you some encouragement, inshallah, to continue learning even in the times that we are right now. Remember, the person who takes this seriously is the one who's going to come out first after all this is over. Okay, so I want you to keep that in mind, inshallah, and continue to work hard and finish strong, inshallah. Okay, so today we're going to learn rational expressions, and a lot of this you guys have been working with most of your middle school careers. So here are a few pointers for you before we start with rational expressions. First off, rational expressions is just another name, Bismillah, for what we in middle school call essentially fractions. Okay, so now you ask yourself, what are all the things that you have learned to do with fractions, right? What are all the things that you know how to do with fractions? And one of the things that you might recall is you know how to add them, right? You know how to add fractions. You know how to subtract fractions, right? So that's something that we're going to be learning. However, it turns out that adding and subtracting fractions is actually a bit harder, okay? So this is, when it comes, usually this is the easier stuff, but in this scenario, this is actually harder. So what we do instead is we practice multiplying and dividing fractions first, right? We're going to learn these first. This is easier for us. And then in the second part of the lesson, we're going to learn to add and subtract. And another little neat note, just to kind of help you understand like where we are in this treatment of things, is realize that we've worked with radicals, right? The roots and stuff like that. And we've learned to add, subtract, multiply, and divide them. And then recently we worked with polynomials, right? And we learned to add, subtract, and multiply them. And now we're working with rationals, and we're learning to do those 4 things with them. So these are basically very important tools that you need to survive well into into pre-calculus, and that's one of the reasons why we learn it. Okay, so let's go ahead and get started. The instructions say reduce each rational expression to its lowest terms. All right, so perhaps some of these initial ones you're like, yeah, I kind of know how to do these, and that would be good. That would definitely be an awesome start. So you're going to find that your best friend when working with most expressions and equations is called factorization. And so really what you begin with doing is you factorize in the numerator and the denominator, right? So in the numerator, it says 4x squared plus 8x. So what you really do is you factorize out the 4x, and you say that what's left over is Bismillah, is an x plus 2, like this over here. And in the denominator, what's really left over after you factorize out a 12 is also an x plus 2, like that, right? So let's just take a side note here and let's talk about something. If I had told you that you have 14 over 16, what would you simplify that fraction to? You would have said that that fraction simplifies to 7 over 8. Now you see, we've been doing that so long, we forgot what part of math even like tells us to do something like that. So I just want to remind you of something. Really what used to happen with 14 over 16 is 14 is the same thing as 7 times 2, and 16 is the same thing as 8 times 2. And you could argue, well, isn't 8 something that you can break down further? Sure, you can break 8 down further into 2 times 2 times 2 times 2, right? We're not like doing any kind of roots or anything like that. We're just breaking down everything into its prime factors. And then you would notice that the 2 here and the 2 here would cross off. And so what you're really left over with is 7 over 8, right? So that's actually why we can simplify fractions. Now, the reason why I bring that back to you is realize that the 7 and the 2 are being multiplied. If, on the other hand, somebody had told you 7 plus 2 and 8 plus 2, let me just ask you this. Are you allowed to then cross off the 2's? Right? And I hope that you're thinking to yourself, no, that's not something you can do. And I want you to remember that. Okay, I want you to remember that because really 7 plus 2 is 9 and 8 plus 2 is 10. And had you canceled the 2's, right, the wrong answer would have been 7 over 8. So just kind of keep that in mind is when you're multiplying 7 and 2 and you're multiplying 8 and 2, you are welcome to cross off the 2's and make the conclusion that the answer is 7 over 8. But when you are adding those 2's to the 7 and the 8, it does not work that you cross off the 2's. That's not how algebra tells you to work with that, okay? So that mini lesson, that side lesson is for this reason. I want you to realize that the 4x is being multiplied to x plus 2. So we factorized it the same way that we factorized 14 into 7 and 2. And we factorized the bottom, so the x plus 2's are two factors that cross off. And so initially what looks like is going to be a 4x over 12, you give it some more thought and you'll realize, wait a minute, 4 and 12 can also be simplified into 1 and 3 because 4 divided by 12 is 1/3. So really the final answer that you get in this situation is x divided by 3, like that. Okay? Let's go ahead and try number 10. Number 10 says that you've basically got x squared plus 4x plus 4 in the numerator. And you've got x squared minus 4 in the denominator. So before we start anything, I'll remind you that you need to factorize. The same way that we factorized the 14 into 7 and 2 and the 16 into 8 and 2 is the same way that you factorize what you have in the top. So you want to think to that previous lesson, which we spent a good amount of time on, right? What is the factorization of x squared plus 4x plus 4? That factorization, basically you're looking for two factors of 4 that multiply to 4 but add up to 4 as well, and so you're thinking of 2 and 2. So the top factorizes into x plus 2, x plus 2, like that. And if you want to argue that can't you just call that x plus 2 squared, you are more than welcome to do that. That's good, all right? That's a good habit. Now let's look at the bottom. The bottom is a different factorization. This is a squared minus b squared factorization, right? And we did lots of questions about that. And we learned that when you have to factorize x squared minus 4, you get x plus 2 and x minus 2, all right? So if you're forgetting any parts of this, please pause this lesson. I know it's going to take some time, but go back to the old lesson, part 3, and watch it very carefully. I teach you part 2 and part 3, actually, and I teach you lots of ways to break down polynomials, right? So now notice how the x plus 2's cross off, a single x plus 2, and you're left over with x plus 2 divided by x minus 2. And that is the final answer, once again, okay? Let's try one more from this here set, and the one that I want to try is number 12. Number 12 says that you've got 3y squared minus y minus 2, and in the denominator you've got 3y squared plus 5y plus 2. So if you haven't caught on, you got to factorize first. So let's take some time and factorize the top first. When you factorize the top, notice that first off, the value of a is not a 1. So because a is not equal to a 1, because that a is not equal to 1, you have to use the long method of factorizing. All right, remember there's a short method of factorizing and then a long method of factorizing. So you're going to have to use the long method of factorizing. At the same time, notice how this 3 is also not a 1, so you have to do the same thing over here. Now, please do not make up any forms of algebra, right? One form of algebra that students have made up in the past, they've said 3y squared goes with 3y squared, y goes with y, and 2 goes with 2. And all of a sudden, they just got these subtraction signs hanging around. They're like, what do I do with this? And they've got a positive 5, so they can make a little bit more sense with that. So this is the wrong kind of algebra, and please refrain from that. A lot of students make that mistake in the beginning. Remember, these things are not being multiplied to one another. These 3 things are being added and subtracted to one another, so you can't do something like that. Okay, now let's go ahead and factorize the top first. The top, let's make it clear just so you can see what's actually there. So the top is going to be negative 2 times 3, all right? So negative 2 multiplied by 3 is going to give you a negative 6. And you're thinking of 2 factors of negative 6 that are going to add up to a negative 1. Yet multiply to a negative 6. So what am I thinking about, right? The 2 factors that you should have come up with are 2 and negative 3. Now let's do the same thing for the denominator, and then we'll look at the factorization of each one of them independently. In the denominator, 3 times 2 gives you a positive 6. What 2 factors will multiply to 6 but add up to positive 5? It's still 2 and 3, and this time they both keep their positives. Okay, now, because we agree that this is going to take the longer method of factorization, let's go ahead and start with it. So the numerator is going to become 3y squared. The 2 middle terms are going to be 2y and 3y with a negative on it. And that last term, remember, it goes unchanged, so it's minus 2. And this right here, when you factorize it, is going to become a y is in common, a 3y plus 2, which is left over. Remember, you copy that subtraction sign and you put a 1 right here. Then what's in common is 3y plus 2, right? It's interesting how you have to switch that sign from a subtraction to an addition. And recall why I explained that to you last time. Negative 1 times 3y gives you negative 3y. We get that. But negative 1 times 2 needs to give you negative 2. The only way they can happen is if you make sure that the 2 has a subtraction sign on it, right? And then the final factorization of the numerator is 3y plus 2 multiplied by y minus 1. I'll remind you, if any of this does not make sense to you, it's because there's a weakness in factorization, and I spent hours on that lesson in planning it and teaching it to you. So you want to take some time and you want to deal with it. Okay, now, that was the numerator. We'll deal with that in a moment. Let's put denominator down. The denominator has 3y squared as well. The 2 middle terms are 2y and 3y, but this time both with positives. And the last term is a positive 2. Now, what's in common between these two? You end up with a y that's in common, 3y plus 2. That wasn't very different. Remember, this time you copy this addition sign, and what's in common is a 1, and you were left over with a 3y plus 2. And then you factorize out the 3y plus 2, and you're left over with a y plus 1, like this, okay? So let's go ahead and go back to the problem. The problem had asked us to reduce what you have in that fraction to its most simplified terms, all right? So just to keep things clear and prevent from anybody getting confused here, let me just take a moment. All right, let me just take a moment and copy that down again. Okay, so we've got that. And we discovered that the top, or basically the numerator, it factorizes into 3y plus 2 multiplied by y minus 1. So that is right over there. That's the top. And finally, we realized that the denominator, it factorizes into everything that is over here. Right? So that is the denominator. So there's that. Okay. Now, we're going to go ahead and set them equal, of course, because that's just a more factorized form of the initial one. Put that division bar there. And now realize that 3y plus 2 can actually cross off. And because the 3y plus 2 can cross off, your final answer is going to be y minus 1 divided by y plus 1. All right, that's objective number 1, for you to basically simplify fractions. And uh, this has barely ever been a problem for most students. After they get past that hurdle of making sure that they don't accidentally simplify things that are not supposed to be simplified, they do a pretty decent job with that section right there. Okay, now what we're going to do is we're going to practice multiplying and dividing fractions. All right. And so let's go ahead and get started with number 14. All right. Number 14, basically all you need to do is perform that indicated operation and simplify the result. Leave your answer in factored form. Okay, so don't expand it after that. So for number 14, it's asking you to multiply fractions. That's probably the easiest thing that you can do with fractions, is to multiply them. But before we start with that, in case you have forgotten how this works, basically if you had something like 12 over 13 and it was multiplied to, let's suppose, 39 over 24, you are welcome to multiply the 12 and the 39 and multiply the 13 and the 24. Now, most students, they have said to me in the past, wait, I thought we had a common denominator. There's no common denominator when it comes to multiplication and division. That's for addition, subtraction, and that's why we teach it later. But one thing that I will recommend to you is you want to pick up is learn the technique of cross canceling. All right, because many times we take away your calculator and you need to have a very quick and efficient way of going about this problem instead of sitting there and going, okay, now what was 12 times 39 and what was 13 times 24? That's going to take you a while, and you don't have a while, right? So one thing I would recommend is you look across, all right? And if you look across, you'll notice that the 12 and the 24 can simplify one another to 1 and 2. Similarly, the 13 and the 39 can simplify each other to 1 and 3. So you see this problem right here, you just found a much simpler solution to it. 1 times 3 divided by 1 times 2. See how much easier that is? And so the answer is going to give you 3 over 2. And if you had done all this big number stuff, you would have still simplified to 3 over 2, but it would have taken a longer time to actually get done. So which are the directions that you can cancel? You can cancel diagonally. Okay, so you can look diagonally and make sure that things can be canceled. You can look vertically and you can make sure that things can be canceled. But that is essentially it. You cannot look horizontally to tell if things can be canceled. So having given you that smaller lesson, I think that number 14 should go pretty well for us, inshallah. So it says 3 divided by 2x multiplied by x squared over 6x plus 10. So remember the secret, you need to factorize, right? Just remember, everything needs to be factorized from here on out, okay? Anything you see that has things in common, start factorizing. So if you notice, the 3, you can't factorize anything in the 3. That's just by itself. The 2x, nothing. The x squared, nothing. But if you look very carefully at 6x plus 2, you can actually factorize out the 2. So this will become a little bit simpler. It'll become x squared, and then when you factorize out the 2, this becomes 3x plus 2, like this. And now you are welcome to look diagonally. Is there anything that crosses off between the 3 and what's over here? Nothing. What about between the 3 and the 2x? Nothing. What about the x squared and the 3x plus 2? No, there's nothing. So all that's left over is you have to look diagonally this way, and you'll notice that x squared and x can actually cancel one another out. So one of the x's from the denominator here cross cancels with one of the x's in the numerator there. All right? And so you have a simplified expression. You have 3 times x divided by 2 times 2 times 3x plus 2. And so altogether, your final answer is going to be 3x divided by 4 times 3x plus 2. You don't expand it any further. It says leave it in factored form. So don't multiply the 4 into the 3x and the 4 into the 2 is what I'm trying to say here. All right, number 16, that's a bit of a tough one because it's going to really take you back to that previous lesson, and I will do that for you. to make sure that you're okay with it. But number 16, it says you've got 12. We get that. And then it says that you've got x squared plus x. So I want you to already start thinking, what can you do to simplify x squared plus, factorize x squared plus x? Then you've got x cubed plus 1, and I want you to think, what have we learned? We certainly have learned something, and it was a hard lesson to learn, but we definitely have learned something that will help us factorize x cubed plus 1. And finally, can you factorize 4x minus 2? You are welcome to pause this video and try this. There's not much more I can really teach you new, but here it is. X squared plus x, it's factorizable. X cubed plus 1, certainly you can factorize it. I will go through that with you again. 4x minus 2, that's an easy factorization. So in this next step, what we're going to do is we're going to focus on the factorization of each one of them. So let's talk about x squared plus x. That you can factorize into x plus 1. Then let's look at the denominator first of this fraction. 4x minus 2, you can pull out a 2 and you can say 2x minus 1. There you go, factorized. Now let's talk about x cubed plus 1. So in the previous lesson, we learned a formula that said if you have something like x cubed plus 1 cubed, you can apply it to the a cubed plus b cubed formula. And the a cubed plus b cubed formula says that you've basically got a plus b multiplied to a squared minus ab plus b squared, like this. And so having said that, if you just apply it to the x's on the 1 that we have, that's x plus 1, x squared minus x times 1 plus 1 squared. So the factorization of the top of this right here is x plus 1 multiplied by x squared minus x plus 1. All right. Now, we're going to do the same exact exercise that we did in the previous problems. I want you to look diagonally, I want you to look vertically, and see if you can cross-cancel anything. So let's start with the 12 and the 2. The 12 and the 2 can become a 1 and a 6. We're done with that. Then let's look at the other diagonal, right? And in this diagonal, you'll notice that there's an x plus 1 factor and there's another x plus 1 factor. So those can also cross cancel. And at that stage, you really don't have much left over to actually cancel. So you've got a 6 multiplied to an x squared minus x plus 1. Remember, you don't actually multiply and you leave it in factorized form. And in the denominator, you've got an x multiplied to a 2x minus 1. And so there's not much you can else do with it. And so 6 times x squared minus x plus 1, leave it like that. And then 6 times 2x minus 1, leave that as well. And that's what you, x multiplied by 2x minus 1, and then put a box around that. Okay? Now, let's try a couple more, inshallah. Let's do number 18. And 18 is a division problem. Please realize that. Okay, number 18 is actually a division problem. Before I get into that division problem, I just want to make sure that you do remember in middle school how division occurs. So let's suppose that I had 75 over 15, and I had it being divided to, Bismillah, 21 over 35, right? So what do you do in this situation right over here? So one of the first things that we try is we essentially say, okay, you're going to take 75 over 15 and keep it the same. Then you're going to flip the second fraction into 35 over 21, like this over here. And then you're going to change it to multiplication, right? And then at that stage, you are welcome to look diagonally as I taught you. 15 and 35. You can cross cancel and you can say that 5 goes into 15 3 times, 5 goes into 35 7 times. And here's something even cooler. You can now look the other diagonal and you can ask yourself, is there anything that goes into 75 and 21? And certainly 3 goes into 75 and 21. So 3 goes into 75 25 times and 3 goes into 21 7 times, right? And what's even more neat is notice how now the 7 and the 7 that are right above one another can simplify to give you 1. And so your final multiplication is actually between a 25 and a 1. That's not that hard. And then a 3 and a 1, which is definitely not that hard. So you end up with 25 over 3. Now, one thing in middle school they used to tell you is make sure you turn everything into a mixed number. Don't do mixed numbers, okay? We don't do that stuff in upper level mathematics, which you certainly are in, by the way, now. So you don't do mixed numbers. You just leave things as improper fractions. That's okay. Everybody understands you can turn things into mixed numbers if you had to, right? So having said that, basically this right here is that division symbol, okay? That's actually where it came from, that division symbol. And so it serves as that division symbol. So I'm gonna, when I write number 18 to save time, I'm gonna write down x minus 2, 4x, and I'm gonna write down divided by x squared minus 4x plus 4, and that is divided furthermore by 12x. Okay, so I think you know what I'm about to say here, right? Factorize, all right, factorize. Look around, see if you can factorize anything. If you want, you can go ahead and flip the fractions first and then factorize. That's fine. If you feel like you might forget, then by all means, you can go ahead and say x minus 2 over 4x multiplied by 12x over x squared minus 4x plus 4. But you still do need to look around and factorize. And what you'll notice is the x squared minus 4x plus 4 can be factorized, right? It's a 4 with factors of -2 and -2. So let's go ahead and take care of that right away, right? And we'll put in x minus 2 and x minus 2. And if you want to call it x minus 2 squared, all the better. Okay, now it's essentially just a multiplication problem, right? So you have to look around and see if you can cross cancel. So let's look in this direction over here and ask yourself, is there anything that can cross cancel? And this factor of x minus 2 can go with one of the factors, not both, but what one of them. And then you look the other diagonal and you'll notice that the 12 and the 4, right, can become a 1 and a 3 like this. And the x and the x can actually cross off entirely, so those are just going to become 1s and 1s, right? And so what are you left over with in the top? You essentially have a 1 multiplied by 3. That's nothing, right? That's going to give you 3. And in the bottom, you have a 1 multiplied by an x minus 2. Now, this step is unnecessary, but I just write it just to make sure that you understand what's being multiplied to what, right? Because students get confused, like, wait, what happened to that fraction all of a sudden? Well, anything that cancels out entirely is going to be a 1. It's not going to be a 0. And so 3 over x minus 2 is our answer to that question. All right, let's try one more, and then inshallah we'll actually wrap up this lesson. So there's not an entire lot that we do in this lesson. It's that next part that takes a little bit more time. So you've got 3 plus x, and you've got 3 minus x. All right, and you are dividing. Now, if we were sitting in class, many times you don't even need me to do all of this work. Students are like, yeah, we can kind of visualize the fractions flipping over and stuff like that. But, you know, you go ahead and you take care of these two spots first. So you'll have 3 plus x and 3 minus x. Those go untouched. But you change to multiplication and you flip over and you get 9x cubed in the numerator. And in the denominator, before we even do it, I want you to think, can you factorize x squared minus 9? Right? And the answer is yes, you can. You can use the a squared minus b squared technique for factorizing and end up with x plus 3, x minus 3. It's because you've got x squared minus 3 squared. And the a plus b, a minus b formula, recall it said that you take the a plus b and the a minus b and you multiply them. So in this context, that would be x plus 3, x minus 3. Now in class, I generally wouldn't need to do that, but because of the fact that we haven't learned this formally together, you might, get confused otherwise. So I did that for you. Now, you want to go ahead and look diagonally. Let's talk about the 3 plus x and the x plus 3. You want to ask yourself this. If I were to give you, think of any two numbers, right? Let's take 12 and negative 5. What's 12 plus negative 5? 7. Okay, now what's negative 5 plus 12? 7. So what I'm trying to imply here is x plus 3 and 3 plus x, it means the same exact thing. X plus y is the same thing as y plus x, okay? So that's one concept to note down. But what if I said 12 minus 11 and 11 minus 12. Now what? Is 12 minus 11 going to give you the same answer as 11 minus 12? No, it's not. Okay, one of them is going to be a negative, the other one's going to be a positive. And so this becomes a major issue for students who don't understand this algebra. So when it comes to an x plus 3 and a 3 plus x, you're welcome to cross cancel or cancel those two terms because they're exactly the same. But if you were to have something like x minus 3 and then 3 minus x, you can't exactly cancel them yet. But let me tell you one thing you could do. Here's a neat little trick. You could say that I'll take the denominator and I'll put a negative sign on the outside of that denominator. And then what that allows you to do is you're allowed to switch their positions and make the 3 minus x into an x minus 3. Let me show you how I didn't change anything. What's negative times x? Negative x. You see that right there? Negative x. And what's negative times negative 3? It's a positive 3. So 3 minus x. It makes sense that I didn't change anything in the problem. But what that does for you is something very neat. Notice how the x minus 3's can now cancel because they're exactly the same thing. And you're left over with 1 over negative 1. So the answer is negative 1. So what I'm trying to say to you here is when it comes to canceling things, x plus 3's and 3 plus x's, don't worry about shuffling them around. Just go ahead and cancel them. But x minus 3 and 3 minus x, you can't exactly cross them off like this, but you can shuffle the bottom one, or the top one, by the way, and by putting a negative sign on the outside, restructuring it, and then making a conclusion. Okay, now, back to our problem and our final problem, really. So in number 20, when we ask, can 3 plus x cross off in x plus 3? Yes, it certainly can. And that's essentially all we have left over, really, right? So you've got 1 times a 9x cubed, which is just 9x cubed. And in the denominator, so here's what's interesting. You have a 3 minus x, and you have x minus 3. If you leave the answer like that, that's okay, but it's not advisable, right? What you should really do is you should take advantage of the little trick that I taught you and say, listen, 3 minus x is the same thing as negative x minus 3. And from before, you already had an x minus 3. Now, technically speaking, your answer can be simplified to look like a more factored form. And a factored form is really, it's a more compact way of representing your answer. So you end up with a negative sign on the outside, and because you have a couple of x minus 3's, you have x minus 3 squared. Now, I always get this question from students, like, wait, are you going to take points off if we don't do that? No, generally I will not, but you will need this skill later on, especially when it comes to addition and subtraction. So it's better to just learn it now than to postpone it till later and then kind of be like, oh my God, I didn't expect this to happen. All right. So thanks for listening and good luck with doing your homework, and Assalamu alaikum.